Hi, Kat here for LightWave Digital. In this video, we're going to be demonstrating the new 3D tracker that is available now in LightWave Open Beta 2026 Build 2. And for the most part, this particular tool is rock solid and has a feature complete tool set with some very few exceptions. But you can get away with using it for just about any shot that you want at this time. And I'm going to demonstrate a couple of shots that I've fired through it just using basically default settings. Here's a shot from a feature film that I did back in 2019 called When Evil Takes Root. It was also called Batabat before they renamed it. And it's a 433 frame long shot. And this originally took me several hours to track in SynthEyes, and I didn't get the best results in the world. However, I was able to fire the shot through with the new 3D tracker, which makes use of the CoolMap technology, and it nailed it absolutely 100% right out of the gate. And it was very automatic, very push button, fire and forget, walk away, and I got a great result out of it. And I didn't even probably have to use the settings that I did. It could have gone a heck of a lot faster if I'd just gone with the lower settings. Now, these cubes that are in here are placed by me so I can test the track and make sure it's not swimming in any way. Typically, in other 3D tracking programs, you'll get little placeholder markers, little upside down pyramids or something similar. I just decided to use the geometry tool and throw in some cubes and throw them in up against some geometry. And you'll see all these little points everywhere that are in our scene once the tracker completes. This is a point cloud that has been textured based off of the image data. And it's very handy for me to be able to use to place geometry in a scene where it should be relative to those points. So if I look at this through the perspective view, you're going to see this crazy kind of splatted array of points everywhere. But inside here, you can see because they're textured, I can make out the side of the window, I can make out the truck, I can make out the balcony window up here on the roof, and I can make up the other window with the sunroof area. And it's very easy for me to get a really good idea as to where this stuff should be positioned should I want to add an additional effect or a prop or something of the sort relative to that space. So this point cloud is something that is generated during the actual tracking process and is essential for being able to place objects in. So you definitely want to use it. When you have a track completed, you're going to get something very similar to this. You can get your fused points, possibly, depending on your settings, your point cloud, and then your dense point cloud. Now, there are a couple of other tools that are thrown into your scene that are placed on various items, specifically the dense point cloud. And it has to do with this 3D point cloud tool, which is new. And it's right here at the top of your drop down options for a custom object appearance handler. And it has some functions like an attenuation to distance. You can choose a soft disk. You can see the difference there. I'll just switch it back. So we go square, circle, soft disk. There is a little bit more overhead with the soft disk shape. You can update it per frame if you want to. But this is essentially a textured point cloud. And it's a brilliant function because we can actually see things for color. We can go in and take a look at where things are. And there's, of course, also the point cloud itself. We're going to just turn the visibility for this off for a second so we don't have to worry about it. And there's the fused points. This has also got the 3D point cloud function on it. We can turn this off so we can just see these items. And of course, you probably don't want to render with this. You can see the whole world there. If you go to points mode for display, you can see what it's done. And again, it's fantastic for being able to see where things are. Absolutely critical for being able to check things out. Really, really important. Anyway, let's get into actually tracking a shot. Now, for this demonstration, I'm going to be using this particular shot here. I'm just going to go fit this to 100%. Nice traveling shot, drone shot down a railway in the Grand Canyon or somewhere in Utah. Who knows where this is? This could be actually not too far away from me as I live in Nevada. Who knows where this might actually be for location? But we want to track this shot. It's 150 odd, 55 frames long, 156 actually, because we're counting from zero. And I want a really nice fast track, and I don't want to bother doing a synthesize track or a PF track or even a fusion track because I want to push button and go and walk away from a machine, get a Dr. Pepper, and come back and have it done. So let's start with that right now. I'm going to clear this scene completely. And we're going to start out from scratch. We're going to go over to the camera panel, and if you don't have these two buttons, which is the 3D camera tracker and the motion pixel tracker, which is a 2D tracker, which can come in handy for various shots, you should go and add those functions in your edit menu layout. Go and type 3D track or 3D, and you have a 3D camera tracker, and just place it underneath of your camera. Remember, Open Beta Build 2 is the current version as of this video recording, so if you have a later version, this is probably already added. If it's not there because you've got different presets for your menu layout, it's the reason why it might be missing. Go and add it. It takes just a second, and you're good to go. All right, let's go and pop up the 3D Camera Track tool, and we'll go through brief menu description here. I'm not going to get into everything because this is all subject to change, but there's very, very few options here that you really need to worry about to get a good solid track out of something very quickly. Let's go and select the folder where this track set of images is. And we're going to go and grab this one. There we go. And we're going to hit OK. It's going to automatically load the entire sequence. And I don't need the quality preset to be anything more than low. That's totally fine. We're going to go and undistort in the track. We're going to go and enable CUDA dense, and we're also going to go low. And we don't need the dense mesh. We do need the cloud settings. We've got the ability to define how many maximum pixels, number of images that's going to check through, the max traversion depth, various settings that are actually all described in a manual that's going to be available quite shortly. That will be on the LightWave 3D website, so you can go through all these different settings. And I will get into this in just a bit. But as I said, this is not entirely perfect just yet, but it's very close. So you'll probably be looking at a very similar menu. Let's hit OK. If you want to generate a dense mesh, you can, but there's a caveat here. Right now, only the Poisson algorithm is available. The Delaunay algorithm, which is intended for exteriors, which this is, unfortunately, there's a missed component off of my system. I don't know what it is. I've sent the error message to the developer. Hopefully, we'll get some information back on that. If I want to generate a dense mesh, though, this is intended for watertight mesh generation, so an interior or something like that. But we're not going to worry about that because we don't need it for this particular shot. But if you want to, you can actually go and generate these types of meshes. And it will be textured as well based off of what ColeMap will spit back through the 3D camera tracker over your image sequence. Since we don't need this, we don't need to worry about it. And another thing that's not 100% just yet is to use the frame range. Right now, if you enable this, it's not going to care. It's going to go through all the frames regardless, so we don't need to worry about this either. A little bit about the import camera, import and a single animated camera and import point cloud. You want, if you're just tracking a shot, you want an animated camera, you can obviously need a camera to import, so that's going to be enabled. These defaults are there to just basically give you what you will be expecting right off the bat. Single animated camera, if you turn that off, you're going to get a camera per frame. So think of that in terms of a photogrammetry setup, which you can use this for. If you had a camera flying around a object or whatever it might be, or you had a photogrammetry setup, you could use this to import all of those cameras and then bake stuff out. There's all kinds of different methods of how you might be able to use that. But for our purposes, we need just single animated camera. Obviously, we want the import point cloud data brought in automatically for us. And if you're having problems with scale, let's say you're flying down a ravine like this one, and it's thinking you're in hundreds of kilometers. You can change the scale factor and re-import with a proper scale, dropping it down to 0.1 for like centimeters in that case, or zero point 0.1 for meters rather than 1 for kilometers. But we're going to go with the default here. And of course, the max points is the maximum limit that it's going to display when it re-imports. All right, center data at origin is another interesting function. It will actually generate everything and put everything into the center of the scene. I haven't tested this extensively just yet because I want to get tracks done, and I think center data at origin may not offset the camera along with that. So you may get a point cloud out of it, but it won't be relative to where the camera actually flies down. So that's something I'm going to have to test because I've come to the realization that I can get really, really, really good tracks out of this without a very long period of time just using low settings. So we're ready to go. And unfortunately, this may be a little bit misleading. You don't hit OK in this step. You actually go and hit auto track. At this point, you're going to be presented with the PCore console, which is the Python console. And at any point, if you need to, you can hit escape to abort this. But you're going to watch how fast this goes through this process. Now, another thing. In your project folder, you're going to see a couple of folders that are going to pop up under a thing called tracking data. Tracking data is going to come up automatically, and you're going to see a folder with JPEGs in it because that's what I named my folder as. And then you're going to get data that's going to be written into here, including a pipeline output log, which will give you a start time if you want to know how long something took, how long the steps were that it went through, what it's actually doing, completing the feature extraction. And this is structured for motion, so image from track. And it's going through all of this right now. So it's completed one of those first steps. It's moving on. Gives you a full log. Now, if you have CUDA on your machine, which you're going to likely have if you have an NVIDIA graphics card, you're going to want to look for an application called NVIDIA App if you really want to know what's going on with your system. So you go over to System, go to Performance, and then you'll get actual statistics coming out of this based off of what's going on in the background. Now, there are certain processes which are not GPU enabled, but there are ones when it goes to create the dense mesh and the point cloud that are. And you definitely want to have that GPU capability because it is quite intense. And if you start fooling around with medium presets or high or extreme, you're definitely going to want the GPU doing that work rather than the CPU. Right now, this is pretty much a CPU intensive function that it's going through. And once it kicks over, it's going to go back and forth. Don't be too concerned if it doesn't hit 100% CPU utilization. It's still using all the maximum resources necessary for it to process the particular set of frames it's working on. And it probably just goes to this amount and then, oh, I'm done that task. And then it drops back down, picks up another task and keeps going. So it's never really going to hit 100% unless it's really, really set to extreme. But it's just going through the process of ramping up and then completing and ramping up and then completing, ramping up, completing. Same thing with the GPU. This is going to bounce up and down from maybe 10% all the way up to 99 and then drop back down. And you'll see it fluctuate continuously as it processes each set of frames. All right, I'm going to pause right here, wait for this to complete. When I did the preview test for this, it took about 12 or 15 minutes. So we'll be back very shortly and we'll see what our results are. Okay, we're back and it is completed. Now, let's not pay too much attention to this elapsed time minutes here of what it just spit out in the P console. Reason being is that there's a number of different steps in here that actually take a bit of time. But let's take a look at the pipeline output log. And we got a start time here, roughly 2049. So 8, let's say it's 8:50. and currently it's 9:02. So it completed. Got to go all the way to the bottom and stay there. So it completed at 9:01 and 32 seconds. So roughly 11 minutes. And let's take a look at what we've got for a result. So move the P-Core console over. And we've got LightWave has automatically kicked out the camera. We have our original camera in here. We need to keep that if we're going to place any additional objects in here just for a bit until we've got them in. We've got our point cloud, and then we've got a dense point cloud, which has the 3D point cloud display tool on it. So we got the distance attenuation, we got the soft disk function. So when we scroll through this, we can see what's going on, and we can see that this track is very much solid. Let's generate a preview for this. And check it against our results. All right, let's play it back. Pretty rock solid in 10 minutes, and I didn't have to futz with it in any other outside 3D tracking software to get this result. Fantastic. Now, let's check it for where things are in the world. Let's take a basic cube. We're going to center it on bottom. We'll give it a width of like 5 meters. Let's go 10 meters by 5. And we'll make sure it's centered on bottom. We're going to save that object out, and we're going to call this cube. And we'll call this cube tall. And we'll hit OK. Boom. This is why you want to keep that extra camera in there so it doesn't try to snap it back. This is something that's going to get fixed in a bit, where you add a camera and the camera is automatically moved back to encapsulate it in the scene. It's more of a new user function, which screws up professional users, so we're going to get rid of that very, very soon. But anyway, now I've got this cube in here, and I need to go find a place to put it. So let's go to the perspective view, and we're going to just center in on this cube. We're going to zoom in, and we can see here that the scale's pretty much accurate. Like 10 meters is a 50 meter, scale size. It's not bad. Probably I would have the scale be larger than this, but it's gone and done this solution here, and I can go and change the scale and reevaluate it if I want. But for the moment, I'm just going to scale this down, and I'm going to go and pop this somewhere that makes sense. Let's say we've got this track in here. I mean the railroad track, actually. And we can see it slightly textured. And I'm just going to zoom in a little bit. My left arrow bracket key, or left bracket key. And I'm going to pop it into one of these spots. Zoom in again. And we'll pop it over to here. And let's take a look at it where we are looking through the camera, just to see what we've got. Let's kind of put it relative to the path of the track. And we can see that it's pretty much spot on. Let's just shrink it down a little bit again, and we'll go and move it. And you can use this point cloud to position things so that you find where you want a object to travel down this track, for example. You want it to really sit there. You can see that this little corner of the cube has been slightly occluded by some of these points. Well, those points are actually part of this bush, or whatever it is, this little rock thing here that's decided to texture based off of that. And we can put that in there, and we'll make another preview here. And you'll see that this thing is absolutely rock solid and locked to that position. If you want to add some more trees down the track, you want to have the track with a train on it, you've got the ability to do that. It's going to make sense because you've got something to position it against. And you can see this cube is exactly where it needs to be, and it's rock solid. So that in 10, maybe 11 minutes, I don't need to go into higher detail or evaluations for this. If I actually want to generate the mesh for something like this, right now, the outdoor algorithm, the Dulani algorithm, isn't functional. But if you have an indoor shot and you want to generate a mesh off of that, you certainly can using the Poisson algorithm. But just be advised that it will take a little bit longer depending on what your presets are for low, medium, high, extreme, that sort of thing. But this is a shot that I've got tracked now. I could have people walking down this. I could have a train going down the tracks. I could have buildings, whatever you want to do, and it's all going to be rock solid. All in about 10 minutes, completely done automatically. Point your tool at the folder of images that you want to track, and away you go. Now, speaking of images, there are a couple of caveats. Right now, the cold map tracker solution in LightWave, because it's depending on the cold map executable, only deals with JPG, so JPEG, JPEG, also JPEG, and PNG file format. Those can be either an 8-bit or 16-bit integer. It'll totally accept it, but it won't take anything beyond that, like EXRs or TGA files or HDRs. Those file formats are not currently functional in that software package. So be advised of that. You can probably go and convert whatever you've got and then deal with it that way. But there is functionality in the tool that will also do dewarping. So if you take a look at what we actually get out of this, there are additional folders in here now that you're going to get for images. There's our original plate. There's sparse. This is the binary files for which you can recalculate from, and then you get depth maps. Now these are in binary format. To convert these back over, that's another step. We'll get into that in a little bit in another video, but you've got the ability to get depth maps out of this and normal maps. So very, very cool. In workflow, you're probably going to want to take your tracking data after you've done a particular shot and back this up to a folder somewhere. Because if you don't, right now at least, if you try to run another track in this project folder, you're going to get into some problems with it overwriting particular data. It may say, hey, I can't build one of these files. Just remember that it's trying to work from what you were working from before. And for example, if I want to go back and do a scale change, or if I want to go and enable dense and I want to reprocess it, or if I want to reprocess working with that original project, I don't have to auto track it all over again. I can just go process dense mesh and I can get a higher consistency mesh out of it. I can get a extreme or a high version out of it. I can change the scale 0.1 or in this case probably 10. Awesome that you can do that, and if you need to, you can port the mesh itself. I don't recommend doing that until we have the proper algorithms for this functioning, but this is coming soon. That'll get sorted out very shortly. And of course, if you are working with an interior, enable texture mapping. That's going to definitely help you because you can use that as a means to light your environment, by the way. Very, very handy tip. Now, a couple of things also in regards to these settings here. Now, while this is the low quality preset, if you start enabling things at high, you're going to start working with estimated defined shape, guided matching. Matcher types originally, when this tool was built, it only had the sequential and exhaustive. Now it has spatial and vocab tree. I haven't experimented with these two just yet, but we will in future videos. But there is a function in here if you have a fast moving shot and you're finding that it's not having the best of time with it. You don't necessarily have to enable high or extreme. You can go to low and just increase the amount of frames that are being evaluated so that it can get an understanding of where things end up. I have tested this on slow moving shots like you've just seen here before, that craning shot from The Evil Takes Root, several action shots from action movies or World War II. It's flawlessly performed, but the one thing that it does have trouble on is shots where you do not have a lot of motion on it. And for that, we've got the motion pixel tracker for doing 2D tracks. You always will need some type of parallax change or some kind of motion so that you've got a understanding that the computer can work with to calculate depth and that depth over time so that you can get the proper motion for the camera. If you don't have enough of that, you're not going to get a track out of it at all, in which case that's the solution to go back to a 2D tracker. Or if absolutely necessary, you can go back to a conventional 3D tracker. But for almost all of the shots that I do in visual effects, including the ones that are the high speed, shaky camera stuff, this thing has swallowed it and it has done a very, very good job of it. So I don't really need to pay too much attention to the details of how much I'm going to have to stress out about getting something done. But for the moment, I pretty much will just go to a low preset, get what I need out of it for a low point cloud to make sure it's working, and then fire and forget, and it works brilliantly.